guys, welcome to the very, very last lesson on quadratic equations and expressions, all of that stuff, factoring. Remember, the end of year assessment includes everything, right? So if you do choose to take the Regents in the summer or when they get it, it will be on everything. So don't dump it out of your brain, but this is the last lesson and we are going to have our test this Wednesday. So make sure you're really, really studying hard, and I know a lot of you are. Okay, so projectile motion, that is where you kick like a ball or throw something. It goes up and then it goes back down. All right, so the warm-up. What are the connections? So before you listen to this, make sure you've done your brain dump, you've done your explanation, or you've written down any questions that you have, right? Okay. So before I even look at whatever they're asking, I just want to annotate it real fast. I can see that this is the lowest y value before it starts going up again, right? So I know that that is my vertex. Okay, I see a 0 here, and the x is 0. That means I have a value for y. So this is a y-intercept. Cool. And then I kind of see that repeating pattern here. So that tells me, hey, it's quadratic. But I could also find the second difference, right? So let me just do that real fast. So I have 11 minus 5 is 6. 6 minus 3 is 3. 3 minus 1. 2 plus 1 is 3. Okay. So now the second difference should be the same. So negative 5 plus 2 is negative 3. Negative 3 plus 2 again, right? So here I'm seeing that common second difference, which tells me, hey, this guy is quadratic. Okay, so there's a couple different things. Over here on the equation, that square also tells me, hey, this guy is quadratic. Okay. All right, so now getting to their actual question, how are they connected? All right, so I have a y here, I have an x here. I know that this squared, I'm gonna have some number squared, right? Something squared plus 2. All right, so let me see. So if I have something squared, right? Like I'm just gonna erase all that. And so if I have, all right, so it's like I have something squared plus 2, something squared plus 2. Those are question marks in case they look like 2s. Question mark, something squared plus 2. Right, okay. So for all of these, I'm going to have something, and that something is what x minus 3, whatever the x value, take away 3, that's what that thing is. All right, so let me see. So let's see. So this number would have to be 9, right, in order for 9 plus 2 to be 11. So let me just write that as 3 squared plus 2, okay. And now let's see, if I have something squared plus 2, that something would have to be a 4, because 4 plus 2 gives you 6, right? Okay, so I could write that as 2 squared plus 2. Cool. All right, so then let me follow that pattern. 1 squared plus 2. 1 squared is 1, plus 2 is 3. Cool. 0 squared plus 2. And for this last one, that would be 1 squared plus 2 again, right? Because 1 plus 2 gives me 3. All right, so it's kind of looking like that. But whatever x is has to have 3 taken away from it. So I look at x. X is 0. So let me try that. 0 minus 3 squared plus 2. So 0 minus 3. So x is 0. 0 minus 3 is negative 3 squared plus 2. All right, and negative 3, oh, I forgot, negative 3 times negative 3 is also a positive 9, so that does work. Plus 2 does get me 11. Cool. All right, so that's one of, like, just playing around with those patterns, and it should work for all of them, right? Like if I chose my x value to be 4, so it should work here. 4 minus 3, right? That's just part of the equation there. Squared plus 2. Okay, let me just put these little guys there. Okay, so 4 minus 3 is 1 squared plus 2. 1 squared is 1 plus 2 equals 3. And that is my x term. Okay, equals 11. All right, so good. So these are like those pattern detecting, those habits of mind that they might seem a little tenuous or tedious. That's the word I'm looking for. Like, okay, I get it. I don't want to do all of this work. But this is kind of where the magic happens, where you can understand how an equation is really related to a table. So that was kind of exciting, not going to lie. But let's move on from the warm-up. I hope that you guys did your full brain dump, copy down anything that you need to, and let's move on. All right, so I'm only going to do one problem tonight. And I say tonight because I'm recording this at night, but today, anytime you get this, right? So I'm going to do problem 1. We're going to talk about it, and then A and B. You only have to do 4 total problems, not the full 8, okay? Because these take a little bit longer. So the reason I just put the problem here is because I want to annotate it, and I want to think about a picture of an actual soccer ball that is being kicked from the ground. All right. Now, all of these words with an initial upward velocity of 90 feet per second, right? So velocity is the speed of something. So it's important to know, but don't get caught up so much in the vocabulary. Try to read it straight through and see, if you can kind of get a sense of what it would look like. All right. The equation is h equals negative 16t squared plus 90t gives the height h of the ball after t seconds. So that's one of the first things I need to note. So this h value here is really like our y values, and it is the height. Okay, and then let me do a different color. All right, here the t value, right, is kind of like our x's, right? I see them here and here. And that is the time in seconds. Okay. Do they tell us what the height is? Oh, yeah, the height is in feet. Okay, so that's really good to know. Let's see. So we have the equation. Oh, so what does a soccer ball look like? So if you have a person, right, and they have this soccer ball, they kick that soccer ball up into the air, right? I'm making it dashed. I don't actually know why. It should probably be solid because it exists every single space it's in the air. And then it falls, right? And so this is kind of like where the ground is. Let me put it in green like it's grass, right? So the height of it would be my y-axis, and the ground is, remember, the ground is time. And so this time would start at 0 and it would end whenever the y value got to 0, right? So like here, whatever the x value is, and we don't know, the y value would be 0. Let me put that x. Okay. Oh, it looks like XO. All right. So the x value we're still trying to find. Here, we already know the x value is 0, right? So it starts at 0 seconds. It ends whenever the y value is 0, right? So these are what we call our roots or solutions, all right? And then the height of it, the highest point right here, remember, is what we call the vertex. So that's an x and y point, neither of which should be 0. And this is my maximum. And I say maximum because it's your highest height, right? If it was your lowest point, it would be the minimum. All right, so now let's see, well, what do they want? So I've done all of this without even thinking, what is the question that they're asking? All right, so same question. Oh, they want the maximum height of the ball. So when we drew that, right, when we drew that and we had the soccer ball come in here, right, they want this maximum point. And remember, that's an x and a y. All right, so you could go to the calculator for all of these. And in fact, I actually think I will. If you don't have a calculator app on your phone, I highly suggest that you get it. All right, so I'm putting in negative 16 x squared plus 90x, right, this whole thing into my calculator. And I'm just kind of getting the table. So I know that the x values have to start at 0, right, because that's my time. And at 0, the height is also 0. Okay. 1 second, the height is 74 feet high. 2 seconds, 116 feet high. 3 seconds, 126 feet high. Oh, this ball's in the air for a long time. Okay. At 4 seconds, it's 104 feet high. 5 seconds, 50. And at 6 seconds, it says negative 36. Okay, so that's not possible. So it lands somewhere here. All right, so it lands in between 5 and 6 seconds. So somewhere in here is where it's going to land. All right. Okay, so the vertex, I don't get a clear understanding of exactly where the vertex is here, right? I don't see that repeating pattern, right, where it's like 116 here and 116 again there. That's not the pattern it's giving me. So that just means I need to do a little bit more work. Now, that work can look like you going into your graphing calculator, and remember how we did second trace, which was really second calc. And what that did was it allowed you to find the maximum. Then you have to go to the left, press enter, go to the right of the vertex, press enter, and then you have to guess, press enter again, and that will give you your answer. But I'm going to do it algebraically because I want to. So maximum, again, means vertex. Okay, and I know that the vertex form will easily show me the vertex. So the vertex form is y equals a x minus h plus k. Okay, so here I know that a is negative 16, right? B is 90, and C, there is no C. Okay, cool. So I already know that a negative 16 will be there, right? Because that's part of the standard form, the A, the B, the C. Okay. So now, vertex form. How do I get this into vertex form? I think what I'm going to do is I'm going to use complete the square. Yep. So negative 16t squared plus 90t, okay, All right, so now let me change my h into 0. All right, and so now I only need these two. Remember, you only need the x squared and the x term in order to make a perfect square. So let's figure out what we need to do to complete the square. I'm just going to erase this for a minute. Okay, so first thing I'm going to do actually is just get rid of the a for now. All right, so that keeps this as 0. That will just give me t squared. And I can keep this as a fraction, but if I put that in my calculator, the decimal isn't too long, so I'm actually just going to write the decimal version. 5.625t. Okay, so now let me make my perfect square, and I am not drawing this very well, but it should be a perfect square. Okay, so now I've got t squared here, and this I've got to split into 2. Okay, so let me just do that here. So if I say negative 5.625 divided by 2, that gives me negative 2.8125. Okay, it's pushing it actually, being too long, but we can work with it. All right, so remember, I can take this half goes in this box, 2.8125t, and half goes in this box, 2.8125t. Okay, so I've just taken the middle term here and I've split it in half. So if you combine those, if you put negative 2.8125 minus another one, you'll get negative 5.625. All right, so now let's complete this square. So I've got t times t gives me t squared. T times negative 2.8125, gives me that. And this t times another negative 2.8125 gives me this. Okay, so now if I do negative 2.8125 times negative 2.8125, I get a positive. Let me see what I get. I get a positive 7.91. Is that right? Okay. So this is what I need to complete that square. So I need to add 7.91 to both sides. 7.91. Okay. So you know I've got to erase, so copy down what you need. Okay, so let me just continue this over here. All right, so 7.91 plus 0 is just 7.91 equals t squared minus 5.625t plus 7.91. So remember, this right here is a perfect square trinomial. All right, and I know that that side, so 7.91, will be t minus 2.8125 squared. Now, we are not solving for t. Remember, go back here. We are not solving for those x values. If we were, then you would square root both sides. We are trying to get this into vertex form. Oops, and I forgot the squared there. Right, that should be x minus h squared. All right, so here I've got the x minus h part. I've got the squared part. Now I want to move this k value, the one by itself, over to the other side. So I'm going to just do that by subtracting 7.91 on both sides. All right, so here I've got 0 equals t minus 2.8125 squared minus 7.91. We are so close to almost being finished, and it kind of breaks my heart that we're running out of room. But, you know, I guess that's what an eraser is for. Okay. So here's something that could be a little tricky. Okay, minus 7.91. I've got to get that A back where it belongs. So in order to do that, I need to multiply everything by negative 16. So I'm going to multiply 0 times negative 16. I'm going to multiply this whole parentheses, that whole unit, times negative 16. And I'm going to multiply this by negative 16. Okay, so 0 times negative 16 stays 0. Cool. This whole unit times negative 16, the whole point of this is to put that negative 16 in front of it. So it's negative 16 times t minus 2.8125 squared. And then negative 7.91 times negative 16. Negative times a negative gives me a positive. Gives me a positive 126.56. So, all that to say, my vertex is a positive 2.8125. Remember, it's always the opposite of what you would think it is in the parentheses with the x. And it goes as high as 126.56 feet high. So this is your height. That's an HT. And this is your time. So in almost 3, in like 2.8 seconds, the ball reaches its highest height of just over 126 feet. Okay, so that would be your final answer. Again, if you just use the calculator and you put that in and you figured out the calculation using the go to the left, go to the right, and have the computer calculate it, you know, I don't hate that, all right? But this is the algebraic way to do it, and we did it by complete the square. Okay. All right, so now how many seconds will it take for the ball to reach the ground? All right, so remember when we were drawing that picture, I don't care about where it starts, right? I know that's at 0 seconds. They're just saying how many seconds will it take for it to hit the ground, all right? And remember, we said when it hits the ground, the y value is going to be 0. All right, so now we are going to solve it. So I'm just going to rewrite 0 equals negative 16t squared plus 90t. And this one, I'm going to factor it, right? I see that it's got, they both have t's there. And then let me see if negative, let me see. All right. Okay, so I see that they both have a t, but I actually am not sure what factors they have in common. So let me just see. So we have 2 times 8, 1 times 16, 4 times 4. Oh, okay, that wasn't so much. 1 times 90, 2 times, is it 45? 3 goes into 9 3 times, so 30. 4, I don't think so, no. 5, so 5 goes into 9 once, and that leaves 4, so 18. Okay, so 6, 6, 6, 6. Let's see, it goes in once, you're left with 30, so 15. All right, 7, 8, 9 times 10. I think that's it, because the next one would be 10, and I've already repeated that. All right, so my highest one looks like it is 2. Okay. All right, and then here I've got 2 of those t's. Here I just have 1, so only 1 can be considered in common. All right, so let me just do my greatest common factor here. All right, so I always like for the what's left inside, the t squared or the t, whatever's left inside the parentheses, I like that to be positive. So I'm not just going to take out 2 here. I'm going to take out negative 2t, right? The 1t that they both share. All right, so negative 2t times 8t, okay? And then negative 2 times a negative 45 would give me a positive 90. And I already have t here once. Okay. All right. So now zero product property. That means that each factor I can set equal to 0. So I've got negative 2t equals 0. And this whole thing, 8t minus 45 equals 0. So here I divide by negative 2. And that just gives me t is equal to 0, which I already have right there. And that's actually where it starts. So it's not where it lands. That's where it's being kicked. So here, 45. Let me see. So I'm going to need my calculator again. So 8. So t would equal 5.625, and this is a time, so seconds. So how many seconds will it take for the ball to reach the ground? It will take 5.625 seconds for that ball to reach the ground. 6 to 5 seconds. Alrighty. So again, these take a lot of time. That's why you don't have a quizzes. You just have 4 to do total on this worksheet. All right. So really be thoughtful about it. Even though it's a lot of steps, you do know how to do the steps. All right. So test on Wednesday. Make sure that you're studying. Tomorrow will just be review day. All right. Questions, comments, concerns, you know what to do. And good luck on the coming test. Bye.